All right, today we're going to talk about something that's quietly revolutionizing how our entire digital world works. It's called software-defined networking, or SDN for short. It's kind of like a massive, invisible upgrade to the internet, and it's making everything faster, a whole lot smarter, and way more flexible. So, let's get into what that actually means.
To really wrap your head around SDN, you first have to ask this question. Seriously, our lives run on the cloud, on big data, on a million different mobile devices. But the fundamental architecture of the networks holding it all together, it was designed like 30 years ago for a much, much simpler world. That old road plan is causing a serious traffic jam today.
And that brings us right to our first stop, understanding today's network traffic jam. Before we can appreciate the solution, we really have to get a feel for the scale of the problem and why the old way of doing things is just completely buckling under the pressure.
So check this out, because this is a really big deal. The way traffic moves has totally flipped. See, old networks were built for what we call north-south traffic. That's simple. Your computer talking to a server. Predictable. But modern apps? Oh no. When you ask for a web page now, a dozen different servers inside a data center might have to talk to each other to build it for you. That chaotic internal chatter is east-west traffic, and the old, rigid networks were just never, ever designed to handle that kind of frantic back and forth.
And it's not just the traffic patterns. It's this perfect storm of new demands. Every one of us has a phone, a tablet, all wanting to connect to corporate networks. Businesses are all in on cloud services, which means they need resources that can scale up or down in a heartbeat. And then there's big data, which isn't just a buzzword. It means thousands of servers need to talk to each other directly to crunch enormous amounts of information. The old, clunky hardware just can't do it. So, to fix this mess, we couldn't just add another lane to the highway. A totally new approach was needed. And this brings us to a really radical new idea. What if you could separate the network's brain from its muscle? What if you took all the decision-making intelligence out of the individual pieces of hardware and put it somewhere central and a lot smarter? And boom, here it is. This is the core concept of SDN. It's all about decoupling the network's brain, the control logic, from its muscle, the hardware that actually forwards all the data. In a traditional network, every single router and switch has its own little brain making its own little decisions. SDN says no. Let's take all those little brains and consolidate them into one super smart software-based controller. The hardware just becomes dumb, efficient muscle that does exactly what it's told. This analogy is just perfect for understanding how it all works. Think of your network as a big city. In the old days, every traffic light at every intersection just kind of guessed what to do based on the cars right in front of it. Chaos, right? With SDN, you have a central traffic headquarters. It sees the entire city map. It sees all the traffic in real time, and it tells every single traffic light, the network switches, exactly when to turn green and when to turn red to create the absolute best flow of traffic possible. It's total, centralized intelligence.
Okay, so we've got the big idea, but what are the actual moving parts? How does this thing actually get built? Let's peel back another layer and take a look at the key components that make up the SDN architecture.
So, there are really just a few key players here. You've got the controller, that's our traffic HQ. Then there's the data path. That's the actual hardware, the switches and routers acting as our intersections and traffic lights. And the magic that connects them? APIs. Think of the southbound APIs as the signals going down from the brain to the traffic lights. And the northbound APIs are the requests coming up to the brain from applications, kind of like a city planner asking for a new traffic pattern for a big event.
Okay, so that's the theory. It all sounds great, but where is this technology actually being used? Well, it turns out SDN isn't some far-off future tech. It's already out there, reshaping our digital world in some really big ways. Let's look at a couple of them.
Probably one of the most widespread and successful uses is something called SD-WAN. That's short for Software-Defined Wide Area Networking. And it basically takes all these same smart principles and applies them to the giant networks that connect a company's offices all across the globe. See, the old way for a big company to connect its offices was to lease these incredibly expensive private network lines. They were reliable, but super rigid and took months to set up. With SD-WAN, a company can just use a bunch of cheaper, regular internet connections and let the smart, central software figure out the best way to route traffic. It's way cheaper, way more flexible, and you can change things in minutes, not months. It's a total game changer. Now, the other huge area where SDN is making waves is security. Think about it. When you have one central brain that can see the entire network at once, you can spot and react to threats in ways that were literally impossible before.
Yeah, because the controller has this God's eye view, it can spot the patterns of a big attack or see a virus trying to spread from one machine to another. And it doesn't just see the problem, it can act instantly. It can reprogram all the switches on the fly to block the bad traffic at the source. It even lets you do crazy cool things like moving target defense, where the network constantly shifts and changes, making it an absolute nightmare for an attacker to find anything.
So, let's pull all of this together. What does this really mean for the future? As we've seen, SDN isn't just a small technical tweak. It's a fundamental shift in thinking. It's about moving toward a future where our networks are truly programmable.
And this quote right here, this nails it. This is the whole point. The magic word is programmable. By separating the brain from the muscle, we can now just tell the network what we want it to do. An application can request a special high-speed path, and the network can create it automatically. This is a massive, massive leap from the old days of manually configuring every single box by hand. And this whole move to software doesn't stop with the controller. SDN often has a partner in crime called NFV, or Network Function Virtualization. So if SDN puts the network's brain into software, NFV takes all the other specialized tools like firewalls, load balancers, that kind of stuff, and turns them into software too. Instead of buying a bunch of physical boxes, they just become flexible apps you can spin up whenever you need them. Together, they create a truly agile, top-to-bottom, software-based network.
And that really leaves us with this final thought to chew on. For decades, the network has been this rigid, complicated thing you just had to work around. But SDN is turning it into a flexible, programmable platform. So if the very fabric of our digital world becomes as easy to shape and mold as a piece of software, what on earth are we going to build next? The possibilities are pretty much endless. Thanks for watching.